Assalamualaikum warahmatullahi wabarakatuh. My name is Afin Zakrieli. I am from Group 8. We'll be presenting about sequence and series for Algebra PBL. So these are my group members. Our group members consist of 7 people. First is Muhammad Dani Luqman bin Nur Hizam and myself, Afin Zakrieli, Ahmad Faiz bin Abdul Rasid, Muhammad Fahrin bin Nasbullah, Edi Zuhairi bin Semaun, Muhammad Wais Nasad bin Fazli, and lastly, Muhammad Irfan bin Omar. So this is task 1, part 1 Philas table. First fact is a machine will produce 200 units daily with an additional output of 15 units per day. Next, the target output is 5,000 units within 20 days, and daily increase in production is consistent, which is 15 units. For the ideas, we use arithmetic progression formulas to calculate the production. We also check if the cumulative production over 20 days meets or exceeds the target. We also calculate specific production values for the 10th day, which is the total for 14 days, and also total for 20 days. Next, the learning issues. We encounter on how to calculate production for specific day or cumulative production. What is the total production over 20 days? And is the daily production rate sustainable to meet the target? Our action plan is we apply the formulas for the n term, which is Tn equals to A plus D times n minus 1. And sum, which is S, stands for sum. Sn equals to n times 2 and times 2a plus n minus 1 d. And we calculate using the S20, which is the sum for the 20 term, using the sum formula. We solve for the 10th term, which is T10, and also S14 and S20 using the appropriate formulas.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Faiz bin Abdul Rasid, number AA241439. So today I will present solution for part 1, task 1. So the question is, a machine produces 200 units daily with an additional output of 15 units each day. So the first question is, how many units will be produced on the 10th day? So we know that the first term is 200 and D is equal to 15. So for this question, we use formula Tn equal to A plus D times n minus 1. So we substitute the information given to this equation and we will get the unit that produced on 10 day, which is 335 units. So we go to the question 2. What is the total production over 15 day? So for this question, we use formula Sn equal to n divided by 2 times 2a plus n minus 1d. So we still use the same information that first term is 200, D is 15, and N we use 14 because we need 15 over 15 days. So when we substitute the information, we will get the total production over 15 days, which is 4,125 units. So the last question is, will this output rate be sufficient if the target output is 5,000 units within 20 days? So to prove this this question, we use the same equation, which is Sn equal to n divided by 2 times 2a plus n minus 1d. So we substitute 20 for n, 200 for first term, and 15 for d. So we will get 6,850 unit, which is exceed 5,000. So the production in 20 days is 6,850 unit. It exceed the target, which is a 500 unit. So the output rate is sufficient. So that's all from me. Thank you.
Assalamualaikum. My name is Muhammad Irfan bin Omar. My number metric is AA240804. I'm from Group 8. Today, I'm going to explain about task 1, part 3. So the question goes, if the power consumption increases by 10 kilowatt-hour monthly due to inefficiencies, what would be the net energy generated by the end of 12 months? So let's look at the Philas table. Facts: monthly energy consumption increases by 10 kilowatt-hour. Ideas: understanding how to apply the formula for the sum of arithmetic progression. Learning issues: what is the formula to calculate the total increases over time? So the action plan is use the formula for the sum of an arithmetic sequence to calculate the increases. So here's the solution. Month 1 is 10 kilowatt-hour, month 2 is 20 kilowatt-hour, and month 3 is 30 kilowatt-hour. And for the next month until 12 months is 10 multiplied by number of months. So the arithmetic formula we use is Sn equals to n divided by 2 bracket divided by bracket A plus L. So n is number of month, which is 12. A, energy in the first month, which is 10 kilowatt hour. L, energy in the last month, 20 kilowatt hour. So we will substitute the value into the formula as 12 equals to 12 divided by 2 and multiply by 10 plus 120. So the final answer we will get 760 kilowatt hour. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. I am Edi Zahiri bin Semaun, number matric AA240308. Will explain our task, which is Group A, Group 8, Task 1, Part 2. And the question goes, if the company implements a maintenance policy to reduce annual depreciation by 1%, how much would the machinery be worth by the 8th year? But in this question, there are no value given, so I will going to explain it in a simple term, which only uses unknown. So, for facts, a company implements a maintenance policy to reduce annual depreciation. Depreciation. Ideas, understanding the formula to apply in order to calculate the annual depreciation. Learning issues. What is the formula to calculate depreciation? And the action plan is to use the formula, which is Pn equals to Pn minus 1 bracket 1 minus R minus bracket n minus 1 over 100, which is the formula needed to calculate depreciation. So for the solution, we uses Pn. N is the number of years, which is the initial value is P0, initial machinery value, and R is the rate of the depreciation, which is 1% per year. Therefore, the value of machinery can be calculated such that P8 equals to P8 minus 1 bracket 1 minus 1 minus 8 bracket 8 minus 1 over 100. But we cannot get an exact answer because there are no value given. So that's all. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Dani Lukman bin Nur Hizam. My number metric is AA241095. I'm from section 6 in Algebra class. Today I would like to present my PBL question, which is the task 2 part 1. So the question is, what would be the machinery's value after 10 years if an annual maintenance policy cuts depreciation by half starting from the 6th year? So before we start to calculate and solve the question, we need to divide this question to some part. The first one is the facts, which is the question needed. And then the second one is the ideas. And then the third one is the learning issue, which is the problems in this question. And then the fourth one is the action plan, which is the formula that we will use to calculate this question. So first one, the fact is a company cuts its annual maintenance policy depreciation by half, which is from 1% to 0.5 starting from the 6 years. So as we know from the task 1 part 2, the first depreciation is the 1%. So after that, the ideas for this question is to understanding what formula and solution to apply in order to calculate the new depreciation to determine the machinery's value after 10 years. So in this question, we also have the learning issue, which is how to solve and calculate the new depreciation and determine the value of the machinery. So after we know the problem, we need to know what the formula we need to use in this question. So for the action plan, we will use the formula Pn equals to Pn minus 1 in bracket 1 minus R minus n minus 1 divided by 100. So for the solution, the first one is we need to know the initial value, which is in this question they didn't provide the initial value, so we will don't know the exact value of this machinery. So for initial value, we will set it as the P0, which is the initial machinery value. And then for the initial depreciation rate, which is R, we have two types of the rate. So the first one is the 1% from the first until the 5th year. And then after the 5th year, which is the 6th year and above, it will become the 0.5% after the company cuts it to the half. So to solve this question, we need to do two calculations. So by using the same formula. So for the first until the 5th year, we need to use the P5, which is the P5 is the 5th year. So P5 equal to P5 minus 1 in bracket 1 minus 5 minus 1 divided by 100. So after the 6 years, the company changed their depreciation rate, which is become to 0.5. So for after 10 years, we need to use P10, which is the 10th year. So the P10 equals to P10 minus 1 in bracket 1 minus 0.5 minus 5 minus 0.5 divided by 100. Sorry, 0.5 minus 5 minus 1 divided by 100. So for conclusion for this question, in conclusion, after 10 years, the value of this machinery still decrease, but it's still not too much like before in the first until the 5th year, since the company cuts the depreciation rate, annual maintenance policy from the 1% to 0.5. We cannot provide the exact value since this question didn't provide us the initial rate of this machinery. That's all from me. Thank you.
Now we will move to task 2 part 2. I will explain about the periodic table according to the question. The first fact is output double each month. The idea is to calculate the point is where storage costs exceed revenue. The learning issue is how to calculate the doubling effect on output and revenue. So the action plan and resources need is research on exponential growth calculations. The second fact is need to estimate when storage costs exceed revenue generation. The idea is consider different storage cost models and revenue models. Learning issue is understanding different storage cost model. So the action plan or resources need is gather data on storage costs and revenue generation rates.
Now we move to part 2. With the output doubling each month, estimate when energy storage costs might exceed revenue generation. Propose solution to address this scenario. Okay, now we have to restating the problem. The output doubles each month. Estimate when energy storage costs might exceed revenue generation by analyzing the sequence formed by the production output. Propose a strategy based on this analysis. Solution using sequence and series. Given information, output starts with QO in the first month. It doubles every month. Q1 equal to QO, Q2 equal to 2 multiplied by QO, Q3 equal to 4 multiplied by QO, Qt equal to 2 powered by T minus 1 multiplied by QO. Total output after n months is the sum of the terms. Sn equal to QO plus 2 multiplied by QO plus 4 multiplied by QO plus 2 powered by n minus 1 multiplied by QO. Now we have to identify when cost exceed revenue. Energy cost is proportional to Sn. Revenue is also proportional but grows slower. Focus on how fast the sequence Sn grows relative to revenue. Summation of the series. Total output after n months is Sn equal to QO multiplied by 1 plus 2 plus 4 plus 2 powered by n plus n minus 1. Use the summation formula for powers of 2. Sn equal to QO multiplied by 2 powered by n minus 1. Now we have to find n. Assume energy cost equal to C multiplied by Sn and revenue equal to R multiplied by Sn. Now we can solve. C multiplied by Sn bigger than R multiplied by Sn. From that equation, we have to cancel Sn. Now we got C bigger than R. The point where cost exceed revenue depends on C bigger than R and how Sn equal to QO multiplied by 2 powered by n minus 1 grows rapidly with n. Now for the last one is proposal to address growth. First, limit doubling. Introduce a cap on output beyond a certain month to prevent exponential growth from overwhelming storage capacity. Second, energy optimizing. Improve energy efficiency by reducing the cost per unit. Third, storage expansion. Upgrade energy storage system in line with expected growth. That's all for me. Thank you.
So the first solution is to optimize energy output and storage. Invest in modern energy storage systems that are more efficient and cost effective. For example, advanced batteries like lithium-ion can store more energy without breaking the bank. Second solution is to monetize excess energy. Don't let surplus energy go to waste. Partner with energy companies to sell it back to the grid or deal with businesses needing extra power. The third solution is reduce storage costs. Break up storage into smaller, localized systems. This can reduce transportation and maintenance costs. Negotiate better deals with your storage suppliers. Bulk order or long-term contracts can save much money.